The answer to this one should be 5.
Oh, I got it.
Answer on this one is negative 21. Answer for this one is 4 times the quantity, 3x minus 5. This is a difference of 2 squares. Come on up, Jones. Answer should be x plus 5, x minus 5. You can factor out a 5 from both of these to start with and be left with x squared minus 4. But x squared minus 4 is a difference of 2 squares. Homework check from after the test on Friday.
This is what you pay for not to look at. I have a question.
We have 8 out of 18 with homework today. And that translates into 44%. If you have credit for your homework, pick a number from 1 to 20 and drop it off up here. The winning numbers are 8, 11, 13, 14, and 18.
Number 13 says, no line, Holly.
I wonder when people listen to these videos from like Japan or
times I've
something
read
and they
this?
hear Holly going the whole period and they're just like, who is that in the background?
I watched your videos just to see if I could hear us.
And you can. And you can.
Yeah. This one's been recorded for about an hour. We've been talking about.
Yeah, 20 seconds. Factor this out. I need the block letter only. You can take out a 4x from each of those items and be left with an x minus 2y squared. So that would be choice C. Homework answers. Number 1. Well, I'm not going to read them off. I'm just going to leave them there for you to check, and then I'll flip the page when you're finished. Here's a quick review. What is this?
2.
And Bobby Joe didn't say stupid when I said, what is this? Yes, the answer is 2. What about this one?
X cubed. Right. Oh no, it'd be x over 1 over 2x cubed.
Right.
Yeah, there you go.
1 over 2x cubed.
1 over 3x.
1 over 3x.
Oh no.
No cubed. Cancels out.
4x cubed. X to cubed. 4 over x cubed.
Yes, 4x to the cubed.
Over
Yes.
3.
Over 3.
1 over 2y.
1 over 2y.
1 over 2x cubed. Squared.
Squared.
Squared, I think cubed. My goodness. 2x squared over y. Oh, no, y. Yeah, y squared.
Y squared, yeah.
Oh my gosh, I got it. I'm like, no.
What's this one?
No. Z squared over x.
Not z squared. Just z.
Oh, over. Oh my gosh.
X. Yeah, z over x.
Yell louder for you. Okay.
What about this one?
X cubed over y. Yeah.
X cubed over y.
Yeah, no.
Last one.
X, y. Oh, no. X. And then over 2 y squared. Oh, wait, cubed. And then
Just 2y.
2y. Oh, that's a.
2yz, yeah.
Okay. Oh my gosh.
Lottery for everybody. Alright, the winning number is 6. A and A plus tests from Friday. So we had Jones, Rayburn, and Applegate for second period. And Rayburn not only had the high score here, she had the high score for the entire day of all classes, including Algebra 1. A perfect paper. And for third period, we had, well, not actually third period, but Davis and Applegate are in this period, but McAllister's in third period. He had
Good job,
a
Leslie.
high score for that class, which was
Good job, Bob.
941.
This is the lowest grade I got. See, I did it on this paper too.
All right, on the test review, my key ended up being not photographed, so since Rayburn had a perfect paper, we'll just use hers. And here are the answers for the test, starting up here at 1 through 5. You can take a look at those, then I'll move it. Here is 6 through 10.
Stupid square root things.
11 through 15. And the bonus, A through E. Today's Common Core objective. Construct a rough graph of a function, and we're going to start at the bottom. The very basic stuff we're going to do is to graph items that are in this form. AX plus BY equals C, or not equals C, but plus C equals 0, and so on. Here's example 1. Alright, here's example 1. You're going to be given a quadratic equation, and you have to decide how you're going to come up with some critical values. And in the most basic, easiest kind, such as this one, you're going to first check to see if it is factorable. If it's factorable, that'll give you the zeros of the function, where you can go to the x-axis and mark those off. So check this one out. Is this factorable? Well, you can't factor it term by term, as in taking an x out of all three terms, but you could also try factoring the quadratic equation as two numbers that multiply to give you a negative 6 and then add to give you the 1x in the middle. Will it work out that way? No, I mean, can you figure out two numbers that multiply to give you a negative 6 and then add to give you a positive 1 that's here in front of that? What two numbers would that be? Negative 3 and 2. Okay. How about negative 2 and 3? Yes. Alright, so we would come up with this. Y equals two sets of parentheses. And if you had a positive 3 and a negative 2, if you multiply 3 times negative 2, you get negative 6, which is here. If you add these two together, you get a positive 1. So that can be factored in this fashion. When you go through to find the zeros of the function, it's the same as setting this equal to 0 and this equal to 0. Or you can just reverse the signs of what you put in. But in either case, when you solve this one, for x, you end up with a negative 3. And when you solve this one, you end up with a positive 2. Those are the zeros of the function, and we're going to hold those for right now and use those on the graph paper when we go to the next screen. But there's also something else you need to graph this, and that would be the axis of symmetry, which also contains the vertex of this. The vertex can be found by doing this. The vertex is going to be negative b over 2a. So you would have to go back to the original problem up here and find out your a, b, and then your c. Your vertex will be negative b over 2a. So plug this in, and your b is 1, your a is 1, so you come up with a negative 1/2.
Where'd you get the 1 after the x?
What you just found here is the x value for the axis, or for the vertex, and this is also the axis of symmetry. So if it's x equals a negative 1/2, that'll let you know where this graph is going to be. So this by itself is just the axis of symmetry. And we're going to write that down and take it with us to the graph paper here coming up shortly. here's a quick review of what we've done up to this point. Your A, B, and C come from this spot here, but before that we found that this was factorable. So we factored it out and came up with the zeros of -3 and 2. This is where they're going to cross the x-axis on the graph. Then we found 1/2 of the vertex, which by itself is just the axis of symmetry. It's -b over 2a, and you plug in your a and b to get a -1/2. That is the x value for the vertex. The last thing you have to do is to find the y value. And to do that, you go back up to the top to the original function, and you plug in your x value for the vertex into that function for x. So it's x squared plus x minus 6, so that would give you a -1/2. The quantity squared of a -1/2, which will come back to be a positive value, and then plus a -1/2, and then minus 6. So you have to evaluate that out, which should be no problem on the calculator. But up here on the screen, I'm going to make this a +4 minus 1/2 minus 6, and get a common denominator all the way through of 4. So this one stays the same. This one is 2 over 4, and this one will be 24. So I just have to simplify this out since I'm not using the calculator. That is a -4 minus 2/4, which is a -1/4. And on the back end there, is that minus or plus when I went through that?
Minus.
That's minus. Okay, so minus 24 over 4. That'll give me a -25 over 4. And you have to convert this to a mixed number so that you can easily plot it on the graph. 4 goes into 25 6 times with 1 left over. So there's your y value, which means your vertex is going to be what we found here, a -1/2, and the y value is a -6 and 1/4. Okay, so from the values we just found, we had the zeros of the function, and the zeros were -3 and 2. So you go to the x-axis and find -3, make a dot, and then find +2 and make a dot. So we've just graphed the zeros of the function. The axis of symmetry is a -1/2. So if you look in here, zoom in, a -1/2 is going to be right there. So you would need a line of symmetry right through there. So I'm going to zoom out and then go get the line tool and dump this in there. Takes just a second. I'll make it green. There we go. Now we have to draw it straight up and down. That's not what I need. I need the line tool, and here is the line tool. Hopefully this works. Hey, there we go. So I got to draw it off to the side and then move it over so I can be accurate. That graph is going to have the same amount on the left side as it has on the right. Now we need the vertex. The vertex we found was a -1/2, and notice that since the x value is a -1/2, it only makes sense that it's on the vertex. And the y value was a -6 and 1/4. So we'll go in here and find a -6 and 1/4. So here's 1, 2, 3, 4, 5, 6, and this would be approximately 1/4. So we'll use that and mark it off here with a dot. So we have the vertex and we have the zeros. We have the axis of symmetry. Things to pay attention to, and it's obvious once you come up with these, but in some cases it may not be. But in your function, for the quadratic function, if you have a positive x squared, then it's going to be a bowl-shaped item like this. If you have a negative x squared item, then it's going to be a U-shaped, or not a U-shaped, but an umbrella-shaped like that. So clearly this will be a U-shaped. And to make your graph precise, you need 2 more points. So what you could do is recognize that you're here and here. This graph is this wide so far. If you went out just one more to 3 on this one, and you went out to a negative, what would that be? 1, 2, 3, negative 4. If you plug that in for x and come back with points, you can find two other points that help you draw this graph more precisely. So the original problem was y equals x squared plus x minus 6. Is that correct? Okay, so what we'll do is over here on this next page, we just plotted 2 points that we found when we plugged in negative 4 and came back with negative 4, 6, and came back with 3, 6 when we plugged in 3 into the function. To draw your graph, I'll do this in black, and I need to get the black marker out. You must make this a continuously curved shape. You cannot have straight lines in it. So when you come down through like this, try to make a curve there and do the best you can freehand. We're going to put in 3 and get 3 squared plus 3 minus 6, which is 9 plus 3 minus 6. That gives us 12 minus 6 for a value of 6. So we put in 3 for x and came back with 6. There's a point. And we also determined that we would need negative 4 as well. So we'll put in a negative 4 and come up with 16 minus 4 minus 6. That would be a 12 minus 6, which is going to be a 6. So we put in a negative 4 and we came back with 6. So keep those 2 points handy and go back to the graph and plot those 2 points.